Alright, number 88. An electron moves in a circle of radius r around a very long, uniformly charged wire in a vacuum chamber, as shown in this diagram. The charge density on the wire is lambda is equal to 0.14 microcoulombs per meter. What is the electric field at the electron, the magnitude and direction, and what is the speed of the electron? From this diagram, it says that the charged wire is a very long, uniformly charged wire, so we can assume that it is an infinite line. The equation for the electric field of an infinite line is 2k lambda over d, d being the distance of the particle from the line. In this case, d is r, the radius in which the electron travels in a circle. So we now change that to 2k lambda over r. We will now plug in k and lambda to further solve this problem. K is equal to 9 times 10 to the 9th, and lambda is 0.14 microcoulombs, so it is 0.14 times 10 to the negative 6 coulombs over r, which results in 2520 over r newtons, the magnitude of the electric field. Now, in this diagram, you can see that the forces in the x direction on either side of the particle all cancel out, resulting in only the y direction. So the direction in which the electric field travels is always outward and away in a perpendicular manner from the charged wire. Now, the second part of the question is the velocity of the electron. This problem, because we are dealing with an electron in an electric field, we are dealing with a charged particle moving through an electric field, in which the force is equal to the charge of the particle times the electric field. Now, since this is movement in a non-uniform field, and also in a circular motion, we can refer back to the force in a circular motion due to Newton's second law, in which the net force in the radial direction is equal to mass times velocity squared over r. So we will substitute that in for the force on Q. So mass times velocity squared over r is equal to the charge of the particle times the electric field. Now we also know that we are given that the charge of the electron is 1.60 times 10 to the negative 19 coulombs, and the mass of the electron is 9.11 times 10 to the 31st kilograms, negative 31st kilograms. We will now plug in the values, and as you can see, the r's on either side of the equation cancel out when you multiply both sides by r. So now we deal with m times v squared is equal to 1.60 the q times the e, or what's left of it. Now what we're trying to do is solve for v. So we will divide by the mass of the electron and take the square root to find the velocity, thus having this equation. Once we plug it through a calculator, we can see that the velocity of the electron is 2.10 times 10 to the 7 meters per second. So once again, the answers are: the magnitude of the electric field is 2520 over r in the direction perpendicular away from the charged wire, and the velocity of the charged particle, the electron, is 2.10 times 10 to the 7th meters per second. Alright, hope that helps. Thank you.